Chapter 5, Network Layer, the Control Plane. Control plane is also what Polly likes to joke about, the better half of the data plane. Now the reason for that is this. If you think about data plane, that forwarding function there, what it does is simply, right, for each incoming packet, do a table lookup, and you know what to do with the packet. Okay, so for each incoming packet, one table lookup, and that's it. There's nothing really intelligent about it, right? The only thing the forwarding is doing just table lookup, and it's just pattern matching, right? But hey, we are sending all sorts of packets coming from different sources, and they're going to different destinations, right? You cannot be sending these packets to arbitrary directions and hope that they will reach the destination. No. So that table there is really where the intelligence is. That is really guiding the packets to go to the right direction, eventually reaching the destination. So the data plane, the forwarding function, although very busy, working tirelessly trying to forward packets, but it's actually simple, stupid. Intelligence is right here in the control plane, and the intelligence is implemented using these, the routing algorithms. So routing here, what I meant as a function is to find a path for a particular source to be able to send packets to a particular destination, or to find a path so that packets belonging to a flow can flow through the network with the right amount of resources reserved. So routing algorithm there, very intelligent. So in fact, the first part of chapter 5 is going to sound a little bit like you're attending an algorithm course. So Polly will be speaking about two general routing algorithms. So they are graph algorithms. So provided a graph, if you think about it, a network having machines connected by cables is a graph, right? Points connected by lines. So provided a graph, we could calculate, we could compute the shortest path from one arbitrary point to another point. So that is what the magic of the routing algorithms are. So these two general routing algorithms will be implemented on the internet as two routing protocols, OSPF and BGP. We'll talk about these routing protocols later after we finish describing the general algorithm. Now, these routing protocols are running on the traditional routers, where you have the data plane and the control plane. So the routing algorithm is running in the control plane. The control plane of each router might be communicating with the control plane of other routers, and together they complete the task of calculating routes, and in turn generating the forwarding table, and in turn install the forwarding table to the data plane, and in turn the forwarding function can be working really fast. Now, the new model of doing routing is called SDN, Software-Defined Networking. So the one that's doing the route computation is the controller. This is also known as the remote controller, because in SDN, the model is slightly different. You still have the data plane doing the forwarding, but the control plane is implemented outside of the routers. In fact, powerful machines somewhere remote. That's why these controllers are also called the remote controllers. And between the remote controllers, routing is being done where we generate the flow tables, and the CA, the control agent, now in the data plane, that's taking in all these tables being transferred from the remote controller. In between, there's this open flow protocol. Now you should know after chapter 4. So after the control agent receiving the flow table, the flow table gets installed, and therefore the SDN routers can do flow table lookup, do generalized forwarding. Now, the remote controller here, it's actually quite general. Inside the remote controller, you could implement multiple routing algorithms, such as the one used by the traditional routing. You can also implement other routing algorithms, and in addition to all these routing algorithms that could be running simultaneously, and you pick and choose a particular route for a particular pair of source and destination. You could also actually specify preferences or or specify cause, okay, or specify other functions. Okay, so SDN's remote controller, being very general, okay, it's actually working like pretty much a regular computer, okay, or expensive servers. So on these SDN remote controller, okay, we run, okay, operating systems, elaborated operating systems such as ODL or ONOS. Okay, so these are two different operating system architectures, and both have big camps of supporters. So yeah, SDN routers are made available today that both operating systems can be installed, okay, to support route computation, flexible route generation, flexible flow table generation. Okay. So these protocols, as well as these two, okay, of the technical components in Chapter 5, concern the routing function, the second important function in the network layer. In the control plane, okay, we also implement some protocols that is to do this, the management. Okay, so management of the routers or the routes or the packets traveling certain routes. Okay, so those are called the ICMP. So ICMP there is to allow generation of special messages from the routers or from the host to the routers, and routers generating something back. So these are there for the network admin to sort of probe the network to find out, okay, where and what might be going wrong inside the network. SNMP. Okay, so SNMP there, the management protocol is more there continuously tracking, okay, the statistics of the network. For example, number of packets traversing a router, number of packets traversing a route, okay, number of routes on a router, and things like that, so that the network admin can know better the status of the routers, the status of the routes. Okay, so again, for management purpose. Let's go real fast through 5.1, the introduction. Again, network layer, we run two major functions, forwarding and routing. Forwarding is about moving packets real fast from one router to another. Routing, however, is for each router to generate this forwarding table or flow table, or to determine the routes for the packets to move, okay, from one to another router. So in Chapter 5, we focus on the control plane here. The two models, okay, for route computation are these: the traditional routing versus the SDN routing. In the traditional routing, each router implements part of these routing algorithms, and so the route computation is somewhat distributed, and the routers work collaboratively to come up with the best routes. Okay. So there's per router control plane doing the route computation. But in SDN, okay, the route computation is more centralized, running on powerful machines, and also somewhat distant from the physical routers. So centrally controlled. And this control is called the remote controller, as they are being physically distant from the router. More specifically, in traditional routing, okay, the routing algorithm is implemented and running on each of these routers, and they'll be interacting with each other to generate the best routes, therefore coming up with the forwarding tables. Okay, so in the data plane, yeah, there's this forwarding table in the data plane. The control plane there runs the routing algorithm, and together they generate the forwarding table and forwarded and installed in the data plane. Now, the modern routing, the SDN routing, works this way. Okay. There's going to be a remote controller there, okay, doing all the computation and then interacting with the local control agent to install these forwarding tables, or more precisely, flow tables. So router, yeah, data plane here, having these control agent, and then at the control plane, we have powerful machines running the remote controller. Remote controller interacting with the CA, setting up these flow tables.